Okay, guys, we're on 94 now. We're continuing on with 4E. This is kind of a long section, so we've got some more examples that we need to do. I've gone ahead and written on the tablet so that it'll save a little bit of time on the video, and I can just talk to you more. Let me get the shade, I guess. Talk to you a little bit more. So if you're just looking at the problem, it gives you a picture. It gives you, you can see the triangles, and it tells you that there is a relationship between the number of triangles and the perimeter, and it's asking you to come up with what the equation is that describes that relationship. So they ask us to do a few things. They want a table, which means we're going to put some values in it. They want some words to describe the relationship, which we can do only after we make the table and see the relationship, and graph the table and write an equation. So I'm going to start with the table. And here's the table. I am going to start, it doesn't make sense to start with zero triangles. You start with a triangle. If you start with 0 triangles, you don't even have a problem, really. So we start with the first triangle, and the perimeter, of course, we're adding the sides together. So we have 5 plus 5 plus 6, and that's 16. And then we look at adding another triangle, and they show you the picture for this. So our perimeter now becomes the 5 plus 5 that we had up here, but now we have 2 6s. So you can kind of notice a pattern here. When we add a third triangle, we're in this figure right here. We've got the 2 5s that we started with, and we have 3 6s. And finally, in the fourth picture, we've got the 2 5s and 4 6s. So you can see the pattern is going up by 6. Every time you have an increase of 1 triangle, your perimeter increases by 6. So we can go plot these points. And again, I'm going to pick the scale of my axes based on my data. On the number of triangles, I only have to get to 4. So I can spread out. On the y-axis, on the output, the perimeter goes all the way up to 34. So I'm going to go up by 5s on my y or my output axis. So if I were to plot these, I'll see if I can do this. 1 is 16, which is about right there. 2 is 22. 3 is 28. Might be up there a little bit. 4 is 34, which is right underneath 35. So that's the graph of the points I picked. And here are the words that describe exactly what I just said. As the number of triangles increase by 1 each time, so we're going from 1 to 2 to 3 to the 4, x is increasing by 1, our output, our perimeter, increases by 6. So that's a verbal way to describe the relationship. Now we need to plot the equation, or write the equation. So on our examples before, I always told you that I started where n or the x was equal to 0. So if we back it up and we actually filled in n equals 0, from our pattern going up by 6, it would make sense that if n were 0, we would go down by 6, and we would just end up with 5 plus 5. Which is 10. So if we go with that thinking, then our equation is where n is equal to 0, 10, plus for every 1 increase in n, we have 6 increases in y. So the equation of this line is 10 plus 6n. So that is equal to our perimeter, which is a function of n. So this is equal to perimeter based on n. Okay, a few more little questions. Again, this is just filling in what we just talked about. The perimeter is a function of the number of triangles. We can look at the points and say, yes, it is a function because no y repeats with a different x. And we can also look and say this passes the vertical line test. So it is linear. I think that's the next question. Is it linear? But now we have to talk about, is it continuous or discrete? So we go back up here and we look and we ask ourselves, okay, I could possibly draw a straight line through here, but does it make sense based on what our problem gives us? So these are triangles. So if I picked a point in between 1 and 2, 1 and 1/2, I could plug it in a formula, but it doesn't make sense. We don't have half of a triangle. So in this particular problem, this is a discrete graph. It is individual points on our graph. So it's discrete. You can't have part of a triangle. And now when we write our domain and our range, we are actually going to have individual points, not an and situation. So the domain is just 1, 2, 3, dot, 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 all the way up to however many triangles we want to add in our pattern. And the range starts at 16 because the first perimeter is 16. This first triangle right here, the perimeter is 16. So it goes up each time based on our +6 pattern. So our domain goes to infinity as well, and it goes up 6 each time, 16, 22, 28, and so forth. Again, it's discrete. So our domain and our range are going to be individual points. Okay, let me get the recorder back up here. All right, I think I'm going to stop this now, and this will probably be the last video, and we will work page 95 and 96 together in class. If you want to go ahead and look at some of those examples and get a head start on your questions, that would be a good idea. Thanks for watching. And I'll put the video check out there as well, and it will be some of the first problems on the practice for 4E.